because we don't have time. We cannot go through that, but you can look it up. Dr. Elena Kotler, our second panelist, our second speaker, she is sitting at the other side of the table. She is an agricultural engineer from La Molina, the University of La Molina in Peru. She has an agronomic PhD in the University of Belgium, 1995, 2001. She has worked with the Ecology and Geology Institute in basins. Now she is a professor at the Ecological Institution. At Institute, she works in the erosion of lands and the management of basins, water basins, and she is an advocate of the planning and information for planning. She works for an institution that works for the government, for the institutions. She has to convince people who have to make the final decisions in regard, and convince them in regard to objective information, and with the scholars, what is it the government is doing, and see how far my commitment goes. So she will talk about a topic that interests her in regard to the functional aspects of the basins and the importance of water in regard to the processes that operate inside the watersheds. I want to thank the organizers of this seminar. I think it is very important to involve the many insights in regard to the management of the information we have on water. The topic I will present, I don't know, is in regard to the water and the water basins. Why the relation? As Dr. Gonzalez said before, water cannot be analyzed in an isolated manner. Water has a space variability, and this notion happens in the basins, the territory where we can understand the hydrological dynamic, the way we can manage the water, and the externalities of water is in a hydrographic basin. This is why in this presentation I want to underscore the question, what does water mean when we speak, when we refer to basins? When we speak of water quality, what does that have to do with the watersheds? And because this is part of the Institute, how do we use the data? How do we turn them into information? One thing is to have punctual data, to try to see how reliable they are. But then what do they tell us in terms of ecosystems, in terms of health systems, and in terms of risks? When we speak of water in the territory, the water is used. There are many users and many ways to use it. One, it goes through the ecosystem, and based on the health of this ecosystem, we will see impacts happen. If, for instance, we have deforestation processes, deforestation will trigger carbon, nitrates, and salts. And all of this, with the rainfalls, with the runoffs, at some point will reach the water streams and the water bodies. With shepherding, because of the land erosion, we have many sediments that will be on the land, but then will reach the streams. Human settlements, organic contents, and coliforms that we know that 20% in the country, 20% of water in the country is treated, but all of them reach the water streams, the lakes, the lagoons, and finally the oceans. The industries, heavy metals, hormones. To give you some examples, the livestock ranches, and this changes the physical chemical conditions of the water. And agriculture, even if it's a diffuse contamination, it has many organs, and this in the territory of a basin is moving because the runoffs are dynamic. Accumulation is not static in any water body. All these components are found in that territory. Many can become infiltrated depending on the permeability of the rock. They can go deeper and deeper or not, but many of them are found in the ecosystem. And finally, we have to something has to be, we have to read something between lines about the health of the basin, because many of these components are accrued, many of them are bioaccruable, and they remain in the system a lot longer. How can we find the salts that can be dissolved, or how can we find the hormones? But their impact is very different. The impact of the different sediments, of the organochlorinated organs, the time they will reside in the ecosystem, they differ. So everything produces a different impact. All of this is accrued. All of this reflects the basin. So what data about the quality of water do we have? What data do we want? Where and for what purpose? Because we know that a static datum, and what is it we are looking for? What is the question we pose to get an answer? If I want to ask what's the chemical demand of oxygen, it won't tell me anything about organochlorinated or hormones components that I know are there, because I have productive activities in the basin. So what quality water data do we have based on what is happening around the basin? The basin has a characteristic that no other territory has, nor administrative nor ecological. When we have everything that has with this accruing effect, we can see it at delta. At the delta, we can have compile the data of the basin. I cannot subdivide the basin in a hierarchical manner, what we call a sub-basin. Based on the activities, if I have it here or here, I will have a more detailed view of what is happening. But if I know that in these two sub-basins there are different activities, in one we have livestock activities, in others we have industries and human settlements, I will have a mix of components that I will not be able to determine where they come from, because what we're looking for in a basin, and with the focus of the basin, is the cause. We don't want to know what's happening with all the components, but we want to know what is the cause. Where does this contamination source come from? This is why we use this water basin focus, so that I can determine another sub-basin, because I can say this is where we see the most amount of stables and all these runoffs. If I have a great amount of heavy metals, copper, for instance, this is where I will be able to determine it. And if this is the cause, maybe I can manage it otherwise, or I can keep on subdividing it. So this type of characteristic, the way they nest in a hierarchical manner, is one of the great virtues of the watershed, of the basin. If I say I'm going to measure the water quality, but focused on this basin and focusing on the cause, I can be flexible, because it's necessary to be flexible and be able to say, well, maybe it is not everything that is happening in the basin, but maybe what heavy metals are found here, and what is the cause, the root cause in that basin, because I need data that will provide information and that will allow me to make decisions. I cannot make decisions if I do not know the cause. Now, as I was saying, the effects, everyone in regard to the effects of land use, all of them are land use effects, don't have the same array in time nor in the same space scale. If we look at the second part of the slide where we have the nutrient part, what it's telling us is that based on the size of the basin, some components will become dissolved because we have many streams that converge. If I have the formation of nutrients upstream, a small stream of 0.1 square kilometers, I have nutrients, I have deforestation. So these nutrients will go to the next sub basin, and then they will go, then they follow an order of 3 or 4. And then we'll have nutrients, maybe some of them will be absorbed by the argyles or become sedimented. But to have a basin of 50,000 square kilometers, Lerma, Chapala, the deforestation upstream Lerma, these nutrients most probably won't reach the Chapala Lake. They will become sedimented, they will become dissolved in the clays or in the rock. But other components like salts or the organochlorinated components like in pesticides or heavy metals, what they tell me is that upstream Lerma, they are formed and they reach the Chapala Lake. So this is very different. So what can we measure? Where do we want to measure it? We want to know the contamination causes in the Chapala Lake. So we will need to analyze well. For some things, I have to capture them in the upper sub-basin, but in others, I can capture them in the Chapala Lake. I can measure and gauge heavy metals in the Chapala Lake, but I don't know if it has to do with diffuse contamination of irrigation in El Bajío, if it has to do with the porcine stables in La Piedad or to the upper Lerma. So I have this contamination, but I don't know where it comes from. So the handling, the management is an issue, but we all already can see, okay, I can gauge the quality here, but then I can accompany it with another quality measurements based on this, and that the elements are variables in time and variables in the scale, in the territory. I don't know if you can see that there are monitoring sites in Mexico, a lot of dots, monitoring sites. I want to show you here. This is the basin map. This is a basin map, and it was here compounded by INEGI and our institute. And this is a sampling sites, I can tell you. You can see it. There are basins that have no dots, that have no sampling sites. And this is on the chemical demand on oxygen, and here on the biochemical demand on oxygen. So not all the basins are represented here. So when we talk about that. And for instance, some of them are represented. This is the basin of Rio Culiacan. The dark triangles are sampling sites. So you can see in the Culiacan basin, we have 3 sampling sites in the city of Culiacan and below the Culiacan city, right before they reach the coastal lagoons. And they are big establishments with over 10,000 inhabitants. And the the water bodies are certainly dams. So you can see that we have several sub basins. No. You see here a settlement right before the dam. And we can think if there's a community of over 10,000 inhabitants, there will be contamination that no doubt will reach the dam. And the water of that dam at some point, and we can see the rivers, will reach Culiacan, and from Culiacan to the coastal lagoons and then to the ocean. So we don't know the impact of these human settlements on the dam because we have no quality of water information. We don't know what's happening here either because of land use. There's much agriculture here and much livestock production. And so we don't know what water quality is reaching the dam that supplies Culiacan, all these localities, another sub-basin. We don't have any data on this dam, and after the dam, we don't know what kind of water is reaching Culiacan. So it is hard. It is hard to identify the contamination causes. And if we have problems of contamination in the coastal lagoons because of the nitrogen and phosphorus, we cannot say it's necessary to decrease the use of fertilizers. It's necessary to install water treatment plants. It's necessary to what? So we need to, as a standard in the localities, they must have water treatment plants. But the sampling sites have not been assigned to identify the causes. This is Lerma Chapala that has many more water treatment plants, but we have the León city or Salamanca. We have here, this is the entire Bahia. Something that in Mexico we have not given importance to the diffuse contamination. We don't have the slightest idea of what it's triggering. We see the consequences. Most dams have an issue of eutrophication, and we have an hypoxia issues at the extreme of the Usumacinta River. Hypoxia is a lack of oxygen. So we see the consequences, but we have not seen what the cause is, where the amount of diffuse contamination is being produced.
Now, this is logical. Why the sampling sites are not telling us anything about the basins? Because when these sites were established, we were not thinking of the basins. What we were thinking of is we have to see the sampling sites that are most important, and these were the criteria. The quality of water is necessary for human settlements, but not only for that purpose, it's also essential for agricultural areas. For water ecosystems, we have a norm that regulates mangroves, that we don't deforest these areas, but we are not referring to the quality of water arriving at the mangroves. We have an index of wetlands. We know nothing about the amount of water that arrive in the wetlands, not to refer to the Ramsar sites where we have an international convention. Many of the sampling sites, if you can see this in the general map, are concentrated in the lower basins. And it's not that the lower part of the basin, the largest amount of population is concentrated. No, it's in the upper part and the middle part of the basin where people settled down. But this does not lead us to identify territorially the contamination sources. If we are in agreement with this, we have to be more familiar with the basin. And what do we need to have more sampling sites or the number of variables? Because right now the variables number is very restricted. So the next layer, if we want to produce more data, is to say where the new sampling sites have to be placed with what variables. And it's not only rainy season. There are some parameters that last longer in the ecosystem, and they are far more dangerous. So we would have to start with a different type of reflection when we increase the amount of sites to measure the quality of the water. At the Institute, we are interested in turning the existing data into information. What does it tell us? And we have seen the DECO and the BBO. What do dams tell us? The dams, we have maps of the dams, and we have extracted from the chart of Mexico all the important water centers. But what does this existence of dams and water basins tell us? This is a river in Hidalgo with a natural dynamic, and 100 meters ahead it it finds a dam. We know that the dams have an impact in the lower river. There's an impact on the ecological flow. So we want to know what the impact of these dams, this enormous amount of dams and embankments that we have. We have published this in a book in the INEGI. It's a model which is quite complex in the river networks and hydrographic basins where the data of quality of water and impact on the infrastructure are reflected here, and how we can see the river systems that have suffered the greatest impact. Here with the stars is the basins with the highest contamination. So the basins where we have greatest impact and rivers without flow of water is where we have the greatest biodiversity. It's my pleasure to say that this was an important impact for our norm ecological in the ecologic flow. We still have a couple of weeks before Mexico establishes this norm. So we turn this data into information for decision-making processes. As to health and water, work jointly with Dr. Riojas from Public Health, gastrointestinal diseases and mortality of children and adults as a result of these diseases. This was included in the basin studies. Everything having to do with diseases related to water are linked to the basins. And right now we are following a project called Risk to Health due to contamination of the hydrographic basins in order to have predictive models of diseases related to water, diarrhea, dengue, and leukemia. These are the models we have followed. The other is water risks, vulnerability, and flooding. There are no systematic data on river flows. It does not exist. So what do we do in order to know what the risk of flooding is? With a geomorphological approach, because flooding is not only by river flows, it has to do with a geomorphological distribution. We carried out models together with INEGI and the Institute of Geography from UNAM, and the vulnerability of population in view of these floods. A large part of our work is to produce these models with trustworthy data carried out with academic institutions. The other point I would like to refer to is that it's important to update the data. Here it is essential to make the data transparent, and I hope that all the speakers repeat this through periodic publication of statistics on water. Right now we see this, but there are still data that are not updated in a periodic way, like the exploitation of aquifers, the risk of rivers and lakes that are contaminated, normativity in the discharges of water. We have statistics of water, which is good progress, but we still need to make an updated group of information which is homogeneous, that we can compare what's the difference between this year and the next. As to in regard to conclusions, in distribution we are referring to complex problems. It's not only having the water, it's there. It's joint interdisciplinary work with other government institutions, academic institutions, and from the civil society. This has been taught through our practice. It is essential to have this data in order to have predictive models in view of the climate change, and there are models as to how wetlands and lakes are changing due to the climate change based on data that we already have. But we still don't have a great deal of information in regard to our country. We have to increase the information and the data produced by the federal government of sampling sites, taking into account ecosystems. This is not superficial. It is the water systems that will increase or decrease the climate resilience. We have to promote interactive sites where different departments can start adding data. There's not only one department that can have the sufficient force to gather all the trustworthy information and updating data and put in a cohesive way water data. Water data is grouped together, but it should be accompanied by metadata and make a follow-up so you can really extract the data you need to produce the necessary information. So then, I finish my presentation with this slide. Thank you very much.